Okay, silence of the lambs. All right, be quiet. We'll go through this fast. Okay, so piggyback off of what we did yesterday, the last one that we did. Actually, I'll show the two examples. Nope, don't let them in. Nope. Okay. T, yeah, buddy. T. Right. No more. Right, there's your seat. Sit down. Did he make a look? Did he make a face? Did he? No one's gonna write him out. Huh? What? Nothing. Okay. Analyze the zeros and then less than zero, input, output. We talked about this yesterday. You better have that figured out. So we did that example yesterday. Then we did one where we actually had to factor to find the zeros, blah, 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 blah. You can look at my old video to, actually, I won't have the old video. So I'm gonna put a new one for 2.8. So this one, real quick, to analyze where is the function less than 0, first of all, you need to find the x-intercepts by factoring. Pull out an x and then do MA factoring or, unfoil. And then these turn into x-intercepts. And then we know this is an x to the third, so we know the graph should look like this. Boom, 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 through those x-intercepts. So then what do we say x was? Input or output? X is input. What's y? So this means with the graph, when I plug in this x value, an x value between 1 and 1.5, between these two zeros, when I plug in this x value, I get a negative output value. So that means when I plug in like 1.3, for instance, when I plug in 1.3, I get a negative number. That's what that means. Graphically, input, output, you got to figure that out. I can't help you. Bus, get on it. Right? Bus driver Samulus. Can't wait when I do that in my career. Make a career change. All right? So, isn't a negative number less than 0? True or false? Right? And then when I plug in 0, no, when I plug in negative 1 per se. When I plug in negative 1, this graph tells me I get a negative output as well. And a negative is less than 0. When I plug in a number between 0 and 1, like 0.5, apparently I get a positive output. So the graph tells me all of this. So when I plug in 0.5 for x, I get a positive number. Positives are not less than 0. So these are not the solutions. These are the solutions. These are the solutions. And therefore, accordingly, I list those solutions in interval notation. So what we're going to do in the next one is, now I know when it comes to a test, which will be Monday, I'm going to ask you to synthetically divide. I'm going to ask you some tougher questions about, you're going to have to depress this x to the fourth down to an x squared and then find the remaining two zeros through maybe the quadratic formula or something like that. But for this question, to solve this inequality, and because I'm doing this graphically, and because of the time aspect, go ahead and just graph this one, but I got it. So what I want to do is solve this graphically, do this whole input-output thing. What x's that I input give me, what kind of y's am I looking for, by the way? Look at the inequality. What kind of output values do I want? Positive. So those are parts of the graph that are what? Above, or above specifically who? The x-axis in general, but the x-intercepts are going to be key. Lo and behold, look at what happens. And watch how I analyze this. Boom! Okay, so first of all, this is an x to the fourth. So polynomial dance, right? We should see something that looks like this, correct? Okay, so when we see this picture, we fill in the blanks. All right, I see this, then I see this, but then it gets cut off, so I know it's got to go up and then come back down to this. And oh, look at this. So actually, I see everything I need to see. I see 1, 2, and then what does it appear that this 0 is? A bouncer, so it must be a... So instead of finding the intersection, now the only way to find the intersection is put y2 equals 0, and then do intersect. If you have an Inspire, that's the complement. I gave Inspire's complements. You can find actually zeros by opening up that shaded region. So that works pretty well. But for 84s, we want to put y2 equals 0 and find the intersection and the intersection. But here, the intersection may or may not work. What I wanted to analyze is what is this minimum? And if this minimum ends up being 0 for a y value, then it is a bouncing zero. Does that make sense, right? It's the lowest point, and the lowest point is landing right on the x-axis. So for that zero to analyze that it is a bouncing zero, I actually analyze the minimum. And that requires that left bound, right bound thing, right? You arrow over left bound, you arrow over right bound, and then press enter. And then look at this answer. What does that mean right there? Well, I put it right here. And I mark people wrong that writes this like a graphing calculator copy around their tests. Because that just tells me you don't know what this means. This means this. But really, this is actually what number? What number is this? 0. This is a calculator problem. There is a little minor error in the calculations. All right. This is actually 0, and this is actually 2, and it should be. And we can prove that by plugging in 2 for x and getting 0 on the dot. If you plugged in 2.000001, you would not get 0. You'd get like this minute decimal. This minute decimal, actually. All right. So it is 2, 0. And then just for purposes of reminding you how to factor this from these zeros, what is negative 4/3 as a factor? You don't need this for this question, but I'm going back to like if you didn't watch my video when you were supposed to when I was absent, then you complain about Mr. Samuel, blah, blah, blah. Right? Anyway, what's negative 4/3 become as a factor? So if this was a question that said factor this, that's 3x plus 4. And then this one's easy. What about negative 1? What does that become as a factor? So that's 1. And then what does this become as a factor? This is the, taking it all the way home. X minus 2, anyone? Squared. All right, so this could be written like this, and then that would be a lot easier to do. And then you'd actually end up with this picture if it was in factorial. But that's not the point of this question. The point of this question is analyzing what x values give me positive outputs or 0. So actually the answers are the zeros. Oh, and then look at this. So isn't this positive output values here? Right. Positive, right. And then what does it become real quick? 0, but then what happens right after that? Positive. So I think we all should understand that the answers for the x values that are plugged in are negative infinity to negative 4/3, not these, then negative 1, all the way to 2, including 2, and then past 2. But that's what this says. This includes 2 in the answers, and it includes everything before and after it. So I don't have to designate anything special about that 2 being a 0. And then I told last hour, including with you guys, hey, note to self. What if there was no equal sign? What if it was just greater than? Then doesn't that exclude the zeros, right? Doesn't that make the brackets become parentheses, correct? But doesn't that also exclude 2, right? So if I change that to a not equal to and it was just greater than, then it gets a little bit more unique. And I think you would understand that. Is that not really a big deal? Okay, so I thought I'd do that with all the students throughout the years just to get you to understand how a bouncing zero, a zero that is tangent to the x-axis is the mathematical way to express that, is special. Okay, and I said I was going to do this yesterday. I said before we actually do a rational inequality, man, we're over here. All right, a rational inequality. I'm going to analyze some rational functions that we already graphed. Then I'm going to turn them into inequality questions. Interesting, Mr. S. So we graphed f of x. This was number 3 from Friday. Remember this? Number 3 from Friday. I picked a couple special ones, but then someone asked me a great question last hour that we'll talk about because they asked it. So we graphed this, found all this information, got our vertical asymptotes from the zeros of the denominator, got our x-intercepts from the zeros of the numerator. We found out all of this stuff. Like the x-intercepts, this in factor form is x times x squared minus 2x, thrilling video. And then x, and this is x minus, isn't this x minus 4, right? And then x plus 2, right? Right. So 4, 0, 0, 0, and negative 2, 0 are x-intercepts. Hey, what happens at the x-intercepts before and after? The graph changes from what to what? Negative to positive or positive and negative as far as above or below, right? So don't you think the x-intercepts are important? Yes, Mr. Samuelis. All right, and then how about the vertical asymptotes, which are the zeros of the denominator? Which, I'm going to factor out a -3, so I'm going to make this x squared. I'm going to make my life easier. Minus 2x minus 3, is that right? If I divide it by negative, because it's really the same to solve this compared to solving this. It really is, right? And then this factors to become x minus 3, right? And x plus 1. That means the vertical asymptotes are x equals 3 and -1 x equals. Because I want you to look at this. What happens to the right of the vertical asymptote and to the left? Isn't there a change in the graph? Isn't there a change from above to below the x-axis? And then look at this. Isn't this above the x-axis? Then I jump to this side and I'm where? It starts with a B, everybody. Below. It's fun to say words. Is everyone okay? Are you all right? Good. Answer. All right. So, all right, fine. All this other information. It is good to know that there's a slant asymptote. That's just to understand this behavior here. But what you need to understand is the only thing that's critical to solve this inequality is the x-intercepts, because that's where the graph changes from above or below, possibly, and the vertical asymptotes. Nothing else really matters. Okay, now, so look at this. If I solve this inequality greater than or equal to 0, what parts of the graph do I care about? The parts that are what? Above, which is this, right? And then which is this, right? And then stops. Hammer time. And then this, right? Okay, so what's the solution for this? It's these x values, which I want to erase that. So what are those x values? Negative infinity to what? -2. What do I put on -2? Brackets. Because what happens when I plug in -2? What does this all become? I'm actually writing it. What does this become when I plug in -2? 0. Is 0 greater than or equal to 0? True or false? True, because of the equal part. Now it gets crazy. You want to get nuts? Let's get nuts. What's the next interval? What number? Okay, what do I put on -1? Now, someone's going to say bracket. Why do I put a parenthesis on -1? When I plug in -1, what does this become? Undies. Is undefined greater than or equal to 0? Is that true or false? You can't plug in -1. It's a vertical asymptote, which means it's an undefined value for the domain. But right after -1, the graph is above. So that's why I put a parenthesis. And then -1 to what? Now what do I put on 0? Brackets, because when I plug in 0, I get what? 0, and 0 is greater than or equal to 0. Oh, this is not rocket science. This all should make sense. Oh, and it's not done. It's just like, and then what? Parentheses what? 3 to what? 4, and then what do I, not infinity, right? 4 to what? And then 4's got a what? Bracket. And then let's just get crazy with it. Okay, I got people tuning out now. Maybe you just get it now. What if I change it to an equality solving for let's just say less than 0? Well, don't you know less than 0 is these, right? Right? And then this, right? Right? And then this, right? Right? Okay? So, but be careful. What do I put on -2 now? Parenthesis, because when I plug in -2, this becomes 0. Is 0 less than 0? True or false? False. So it's everything after -2. -2 to what? Oh, yeah, -1, that vertical asymptote. And then what? Union at me? 0 to what? 3. And then union that with what? 4 to infinity. And the only reason all of these have parentheses, A, vertical asymptotes can never be a solution. B, this does not have an equal sign. So therefore, I can't include those particular things. All right, so I did do this one real quick. The reason I do 2 more is because some special things happen. And I do want to cover it as a review of how to graph rational functions, if you weren't good at that. Hey, test is Monday. Number one, vertical asymptote, very easy to find. 0 is the denominator. The x-intercepts are very easy to find. The zeros of the numerator. So I graph those. Oh, wait, this is weird. 1, 0, and then x equals -3 for a vertical asymptote. One more thing I should know is, especially for the test, what's the horizontal asymptote? And these x's are equal. So the horizontal asymptote is y equals -1/4, which means very minutely to the left of this x-intercept, the graph is what? Above. But after this x-intercept, the graph is what? Very minutely below the x-axis. But still, that means when I plug in 2, what kind of output value do I get? Negative. That's why I picked this one, because it's so small, it's hard to see, and you got to have more knowledge about stuff than looking at the picture and trying to figure it out. You have to. That's why I told you got to find all this information first, graph it all first, then look at your graphing calculator. Okay, so let's do this. I don't want that. Let's say just greater than 0. Well, after all of that, you should know that this is an output that's greater than 0, and then it stops right at that x-intercept, right? And these are all what? Because this horizontal asymptote controls us. What are these all? They're all below, so I don't want that for this first question. That's it. So what's that interval? -3 to what? 1, and then what do I put on 1 because of this? It's a parenthesis because when I plug in 1, I get 0. And 0 is not greater than 0, so that's a false. And I never have a bracket on an asymptote value because that's an undefined value. All right, so you're getting there. This is actually all the notes you really need. But I'm going to continue with reviewing what the key components are. So I hope you're getting that you don't have to find every piece of information for the graphing. You only have to find the x-intercepts and the vertical asymptotes, because that's where the graph may change from being above to below or below to above. And that's all that matters for analyzing an inequality solver. So for less than or equal to 0, we have to understand that these output values are all less than 0. Ugh, where's my... I'm lost. There we go, green. And then this is actually, it's hard to draw, but all that is y values that are negative output values. So, boy, yeah, too late, right? Negative infinity to what? -3. But what do I put on -3? Parenthesis because it's still an asymptote. And then what's the next one? 1. No, what do I put on 1 though? Bracket, and then it does go to infinity. All right, so it's minor little things there. And then the reason I gave you this one is, okay, fine. Just to remember this one. This was number 11 from Monday's worksheet. Number 11 from Monday's worksheet had something special happen. First of all, the x-intercepts are 0 and -2. Weird. Vertical asymptote is subtract 8, divide by -4, x equals 2. Oh, no, wait, that's the reflection sound. Sorry. A symmetry sound. My bad, dogs. And then you go to the graph. Okay, fine. What kind of asymptote is there here? We should recognize this now. What kind of asymptote? A slant. But does it matter? Do I have to find that to solve this inequality? Let's go greater than or equal to 0 to start off with again. No, it doesn't. What matters is when I look at this picture, I know this all stays what? Below. And then this is what right now? Above. But then what happens between these two? Even though you may not see it in the picture because of the pixels. This goes below. And then it hits this, and then it goes above. Oh, how wild. All right, so for greater than or equal to 0, these are the intervals. I like these y values, I like these y values, and I don't like that at all. So this is -infinity to -2. What do I put on -2? Brackets. Union that with bracket 0 to 2. What do I put on 2? Parenthesis, because when I plug in 2, that's undefined, and undefined is not greater than or equal to 0. Hammering that point down. If you don't still get this at this point, I don't know what's going on. You're staring at ceiling tiles. You're looking at your nails. You're doing something. You're ignoring my annoying, nails on a chalkboard voice. Right, Chief? Nothing. All right, good. Yoink. Yoink. Hooray. Here. What do I put around these two? Oh, not equal. And then what do I always put on this no matter what? Then infinity always gets a parenthesis because you can't get there. It's an idea. It goes on forever. And then someone asked me a great question. It's not that. Let's zoom in. Let's zoom in on this. I like doing this. Zoom in as far as I can and then watch how cute it is when we're done. When I zoom back out, little cute example. Remember these? Remember you had this, then you had a picture like this, and then you had one of these, and then this. What's that called? Pole. And then you had this, right? This is one idea there. So say this is at -2. And then obviously the vertical asymptote is at x equals 0. Say you had this rational function, let's call it a rat, and then say it was less than or equal to, it doesn't even matter, 0. So this rational function that graphs to this less than or equal to 0. I think everyone knows then I care about, wow, look at the size of that. That I want that and that, because -2 still does what when I plug it into the rational function? What does it do? Makes it undefined. So can it be part of my solution set? No. So if this is the rational function that, by the way, I could make this up, but I'm not. Then the answer is -infinity to -2, excluding -2, and then -2 to, I said the vertical asymptote is at 0. That can't be included. So someone asked me, what about holes? You know, when you have something like this happening. Yeah, you got to worry about holes too. Okay, in a random. So I just said, now watch how cute this example is when I zoom back. Aww, isn't that cute? Look at it. Okay, so after all of that, do I have to graph every single part of this like I made you do in 2.6? No, the key values are what? The x-intercepts and the vertical asymptotes, and maybe some knowledge about the horizontal, which we will share, but it's really the, you know, and if there's holes, that is actually some of it, but there's not. So what's the x-intercept? Everyone should know right off the bat. What's the x-intercept? -2, 0. What is the vertical asymptotes? Yeah, there are two of them. X equals 3 and -3. All right, and then what is the horizontal asymptote? Let's just share that so we understand the behavior of the graph. Oh, it's not slant. Oh, no. And it comes from when I plug in a million. What's a million over a million squared? What does that actually become? It actually becomes really small. In years past, I've actually done that. I've actually plugged in x. I've plugged in a million for x on my calculator. I'm going to do that, you know, because you guys got to figure this out. You got to figure out why I'm saying this for these asymptotes. Clear? Okay, so I'm going to plug in a million. 1, 2, 3, 4, 5, 6. And I'm going to stow it in x. I hit x. Come on. All right. Now, watch when I plug in this expression. X plus 2 class divided. This is another way to analyze end behavior asymptotes. I don't care if it bores you. This is actually the math behind what we do here. X squared minus 9. You ready for this? Boom, 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 boom. Hey, what kind of number is that? It's a really small number. Do you see that? Okay, and then what happens now when I plug in negative? I don't care. If I plug in a negative million, I'll get a really small negative number, which is actually a wrong way to say that. It's but it would be a negative 1.000 e negative something. All right, so there's proof again that at the ends, these numbers approach 0, so there's a horizontal asymptote at y equals 0. So then I'm treating this as a little review of how to graph rational functions anyway, and knowing these key components and these key parts. All right, then I go to my graphing calculator and I just graph it. And now I make sense out of this drawing. This drawing is perfectly sensical to me now. X equals -2, or -2 is the x-intercept. The vertical asymptotes are at x equals 3 and x equals -3. And lo and behold, look at it again. When you look to the left of a vertical asymptote and to the right of a vertical asymptote, there's a change from above to below or below to above. And that's what I need to assess when I'm solving an inequality. And then knowing that y equals 0 is a horizontal asymptote is also a value. Because then I know that this part of the graph never reaches what? 0. And this part stays below and never reaches what? 0. So I know there's boundaries. So what do I care about? Where the graph is above or below after everything we've covered the last 2 days. Everything that's what? Below, which is this. Below, which is this. And I don't care about that. Now, I said less than or equal to 0. So the answer is negative infinity all the way to negative 3. What do I put on negative 3? Parenthesis. It makes it undefined. And then this is an x-intercept of negative 2. What do I put on negative 2? Bracket, because when I plug in negative 2, this is 0. 0 is less than or equal to 0. All the way up to what? 3. What do I put on 3? Parentheses. So I do have a little mistake here. This should be filled in. Now, they talk about assigned charts. We're not going to do that. But all it is by, plugging in values. So what you could do, say you were stranded on a desert island and you didn't have a graphing calculator. I know this makes people sad when I say all this stuff, but you can, then this is what you'd have to do. And I do have people that don't have a graphing calculator. You will literally have to find these critical values and know negative 2 is involved in the solution set. And then you'd have to check negative 4. What's negative 4 plus 2, everybody? Negative 4 plus 2? Nobody got that right so far. Negative 2. Hey, all right, then what's negative 4 squared? 16 minus 9 is what? 7. Is this a solution to this then when I plugged in negative 4? Yes or no? So then all of these numbers would be a solution. That's what you're guaranteed because you know what the... So this is if you don't have a graphing calculator. Oh, this really stinks because the number between negative 3 and negative 2, the only one I can think of is negative 2.5. And then you physically have to plug in negative 2.5 and see that you get a positive number. And then plug in 0. That's easy. You get negative 2/9. So that works. So this is if you don't have a graphing calculator. You'd have to do a guess and check scenario. But all that being said, that's what we get for a final answer. Everyone good? I think third hour is about to go in a coma, so I better hurry up and finish this. All right. X-intercepts are the zeros of the numerator. No time. Factor. Know how to factor. Vertical asymptotes, there's only one because this factors. Can anyone factor that fast? X minus 3, X minus 3. So that's X minus 3 squared. All that does is something special for the graph. Now watch this. Watch this. Watch this. This would help you on how to graph a rational function anyway that I don't think happened to you yet. Boom shakalaka. Now I'm going to erase this. And this is what you'd see on your graphing calculator. Oh, isn't that strange? That's what you get when you graph this and put it in the graphing calculator. But wait a minute. I have a vertical asymptote. Nick, right? Yeah. At x equals 3. I didn't say your last name, so it's not illegal I said your name. Now, what you doing back there? And then the x-intercepts are 2, 0. Oh, then look, negative 5, 0. So the graph does this. Then what does it do after negative 5, 0? You even see it. It actually turns to what? Above. And then, remember we said horizontal asymptotes. Did I cover the horizontal asymptote for this? Bummer. Horizontal asymptote rule remembrance. All right, and actually I can prove this on the graphing calculator, bore the students even more. But when it's x squared over x squared, then the horizontal asymptote is y equals 1 over 1. So what I could bore you with is proving that on the graphing calculator. See, I already have a million stored in for x, so I'm going to put the numerator, x squared. Again, another way to analyze end behavior asymptotes, plus 3x minus 10 divided by, oh, you're getting so much on this end behavior asymptotes. Oh, if you don't remember this stuff next year, what is that number close to? 1. When I plug in a million, I almost get 1. Isn't that amazing? Okay. If I change this to like 2x squared, blah, blah, over x squared, then this would be 2. All right, and that's proof of end behavior, y equals 1. So, to get to not beat a dead horse here, which means for some reason to take too long on something, that's what the picture actually does in that. And all I care about is where the graph is above. I'm trying to get the students to actually answer a question. Okay, so the final answer for this is... boom shakalaka in interval notation, this. Negative infinity all the way up to -5, that x-intercept, this graph, believe it or not, is above. And I get positive out. Oh, we got someone getting out that Chromebook. Nice. All right, just these students these days, they're just amazing. 2 with a bracket, all the way to 3 with not a bracket, because you can't have an asymptote or be undefined. And then 3 to infinity after that. All the outputs are above. Done. Now you can do whatever you want.